Assalamualaikum. In this video, I'm going to show you how to solve a maximization assignment problem using the Hungarian method. Now let's look at this example. Now this example is taken from the book Quantitative Analysis for Management by Barry Render, Ralph Stair and Michael Hanna, page 428. The problem is we have four ships here, which are going to be assigned to four sectors of the sea, and we have to find the best assignment so that the total efficiency of the assignment of the ships to the sectors is maximum. Okay. All right. So these are efficiency rating of each ship to each sector of the sea, named as A, B, C, and D. This is how out of 100. So maximum is 100. Okay. So we want to maximize the efficiency rating. We don't want to minimize the efficiency. So how do we do this? Now, first of all, we identify the maximum value in this table, and it happens to be 100. This is the maximum, which is ship number 3 to sector B. So the first step is we are going to convert this table to an opportunity cost table. And how do we do that? We do that by taking 100 minus every value in this table. Okay, so let's look at this table here. Okay, so if we take 100 minus 20, we should get 80. Okay, so we can see that the efficiency of ship 1 at sector A is 20. So if we assign ship 1 to sector A, we are going to incur cost of an opportunity cost of 80. Okay, so how do we get this? Again, 100 minus 60, so we get 40. All right, and same thing here, 100 minus 50, we get 50. So all these numbers are the result of the subtraction of each value here from 100. Okay, so we can see that 100 minus 100, we get 0 here. Okay, so now this becomes an opportunity cost table. Okay, so the next step is we are going to proceed as before. Okay, we have this this is the row reduction. Okay, if we can see here in this table, the minimum for this row is 40. Okay, so 80 minus 40 is 40. 40 minus 40 is 0. 50 minus 40 is 10. And 45 minus 40 is 5. Okay, so same thing for the rest of the rows. Identify the minimum in each row and then take every value minus that minimum value. So we get these values here in this table. Okay, now once we've done the row reduction, next is we are going to do the column reduction. Okay, this is the column. This is the table after column reduction. Okay, you can see that the minimum here is 15. So 40 minus 15 is 25. All right, and 20 minus 15 is 5, and 20 minus 15 is 5, and 50 minus 15 is 0. Okay, so similarly for each of these row, identify each of these columns, identify the minimum. Here 0, so no change. Here 0, so no change. Here 5. Okay, so we get this. So now let's look at how many zeros do we have. We have 1, 2, 3, 4, 5, 6, 7. Okay, so how many lines can we draw? Let's see how many minimum, what is the number of minimum possible lines that we can draw. Okay, so we can draw here 1, 2, okay, hang on, 1, 2, 3, 4. What about this? 1, 2, 3, 4. Okay, so the minimum number of lines that we can draw is 4, and that equals to the number of rows and the number of columns. So this table is now optimal table. Okay, so now we can make the assignment. Okay, so let's look at the row which has 1, 0. So it looks like this is the row. Okay, this is the row that has 1, 0. And okay, so 3 is assigned to shape B. Okay, so 3 is assigned to shape B. Now the next row with 1, 0 is going to be this. Okay, so shape number 4 is assigned to sector A, and the next row with 1, 0 is this one. Okay, so shape number 1 is assigned to D, and finally shape number 2 is assigned to sector C. Okay, so this is the answer here, and the minimum efficiency rating is 300. Okay, so shape 1 to D, shape 1 to D, that is 55. Shape 2 to C, that is 80. Okay, 80. Shape 3 to B is 100, and shape 4 to A is 65. So the total is 300. Okay, so that's it.